Hi guys, here's 1.4 day 1. We're talking about functions and inverses. So we talked about what does it mean to be a function. One definition of it you could say is if it passes the vertical line test. In other words, if I draw a vertical line anywhere on the graph, if I only hit the graph one time, then it would be a function. Also, if you have a mapping or a table, each of your x values, I guess the mapping is probably a little bit more graphic for you. So 1, 2, 3, 4, 5, 6, 7. Each x value goes to only one y value. It's okay if two of them go to the same y value, but each x can only have one arrow going to a y value. So both of those are examples of functions, and what it means to be a function is for each x value, there is only one y value. All right, and then the inverse relation, this is when we take our domain. So remember, this is our domain, all of our x's in our range. And what the inverse does is it flips these guys. So for an inverse relation, everything that was in my range, this is going to be the new domain. And this guy, my old domain, is going to be my new range. So everything from my domain is going to get mapped back to the range. So if I have the point 1, 5, in the inverse, the point would be 5 goes to 1. So the point 5, 1. 2, 6 is a point, so 6, 2 would be in the inverse. 3, 6 is a point, so 6, 3 would be in the inverse. 4, 7 is a point, so 7, 4 is in the inverse. So if you look at this mapping that we have here, this is an inverse relation. So an inverse relation is when the domain of a function is switched and becomes the range and vice versa. So when the domain becomes the range and the range becomes the domain. So if you look at this example that we have up here, if you notice, if you look just at the red lines, notice you've got a 5 going to 1, that's good. But for 6, you got 6 going to 2 and 6 going to 3. So this is my new x, these are my y's. So I've got one x going to two different y's. So this would not be an inverse relation or inverse function. This is just an inverse relation. What makes it an inverse function is when the inverse is a function. So let's explore that down below here a little bit. So I've got two different examples. So for this example, let's first just fill in the table. So I've got the -4 goes to -2. So in the inverse, -2 goes to -4. If 0 goes to -3 in the function, in the inverse, -3 goes to 0. We're just switching the x's and the y's. 1 goes to 2 and 4 goes to 2. So 2 goes to 4 and 2 also goes to 1. Over here for this other table, notice -4 goes to -2, -2 goes to -4, 0 to -3, so -3 to 0, 1 goes to 2, 2 goes to 1. So we're just switching the x's and the y's, the domain and the range. If you notice though, for this one here, when we flip it, and now I've got one x going to two different y's. So this guy here is a function, but its inverse, because the x goes to two different y's, is not a function. Whereas if you look at the second set of tables, the function obviously is a function. And the inverse, all these x's go to only one y value, so the inverse is a function. And we call this relationship when you've got a function and the inverse of the function is also a function. We call them one-to-one functions. So as you explore math further up, you're going to hear one-to-one a lot more frequently. Not so heavy for a couple of years, so don't freak out about this whole one-to-one idea, but all one-to-one means is for each x, there's only one y, and for each y, there's only one x. So both the function is a function and the inverse of the function is a function as well. All right, so why do we care about this? Well, because sometimes we want to explore what the inverse is graphically. And in Algebra 2, we have 3 different pairs of inverse functions that we learn about. Well, I guess you could technically say 4, although the inverse of a linear function is just a linear function, so it's not really a pair. But we're going to learn about quadratics, and their inverse are square root functions. And then we're going to learn about cubics, and their inverse is a cube root function. So we're going to start off with these linear problems. How can we tell this is a linear? Because it's x to the first power. Remember, this is your slope and your y-intercept. If I want to find the inverse of it, we're going to follow the same algorithm each time. So step 1 is going to be change it from function notation into y notation. So y equals 3x plus 4. All right, step 2 is going to be switch your x and your y. So instead of y equals 3x, I've got x is equal to 3y plus 4. Once I've switched my x and my y, now I'm going to solve for the new y. I want to get the new y by itself. So I'm going to move the 4 over. I get x minus 4 is equal to 3y. And then I'm going to divide by 3. So the inverse of this guy is x minus 4 divided by 3. So these guys canceled. I got y is equal to this guy. Last step is to change it, put it back into function notation. All right, moving on to the back side. Let's go through those steps one more time. So we're going to change f of x and call it y, because f of x and y are the same thing. Once we got xy notation, I'm going to switch the x and the y. This is the same thing as switching the domain and the range. Once I've switched the x and y's, now I'm solving for the new y. So I'm going to add 2 to both sides. I get x plus 2 is equal to 2y. And then I'm going to divide by 2. So I get y is equal to x plus 2 divided by 2. Last step is to take this y and put it back into function notation. So I'm saying not f of x, but f inverse of x is equal to the new guy that we found, x plus 2 divided by 2. If when you get to this point you have y's over on this side, you've gone wrong somewhere. So that's a good way to know, at least if you're in the right ballpark. All right, for example number 2, now we are graphing the inverse of a function. So in order to do that, we're just going to pick some good points on it. So how about this point, and this point, and this point, and that'll give us a good sampling here. So I've got the point -4, +4, -2, 2, 0, 0, 2, 2, 4, 4. For the inverse then, we're going to switch our x and our y. So instead of -4 and 4, I've got 4, -4, 2, -2, 0, 0, and then these guys stay the same, 2, 2, 4, 4. We flip them, we can't really tell. All right, so for our inverse, let me draw the inverse in red, even though I wrote the table in black. For inverse, I've got a point at 4, -4, so over 4, down 4. I've got a point at 2, -2, and then 0, 0, 2, 2, 4, 4 all stay the same. And so the inverse of the black graph is this red graph that I'm drawing. And then if you ask yourself, does this red graph pass the vertical line test? Nope. It hits twice, right? So this is not an inverse function. The inverse of an absolute value graph, which we just studied. The inverse of the absolute value graph is not a function, it's a relation. So I really can't put it in this notation here, because we restrict this notation just for graphs that are inverses. So this would just be the inverse. We don't really have a notation for inverse of x. We have it in function notation if it's just inverse function, but not necessarily inverse relation. All right, looking at the second one. Again, we're going to find a couple of good points. I've got 1, 2, 3. And as we saw in class, with just those 3 points, what is that? -1, -1, 0, 0, 1, 1. When we go graph it on our inverse and we flip those guys, we still have the same 3 points. So you guys got a little confused and said, well, what do I do with those same points? How do I know what it looks like? So I know, you guys don't know this just yet, but I know it's a cubic function, so I can find another point. But let's say that I didn't. I could say this point here is roughly what? Roughly -1.5 and down 3. And again, roughly 1.5 up 3. Let's flip those guys. So then I would have the point 3, -1.5, and the point 3, 1.5. Sorry, this should be -3. So -1.5 is down here at -3. Positive 1.5, positive 3. So using those points, I have some inverse points that'll be a little bit easier to draw. So there's the 3 points that they have in common. And now I've got the point -3, -1.5, which is roughly here. And the point 3, positive 1.5. And so here we go. And there's our inverse function. So again, just to wrap up for graphing, you find a couple of good points, you switch your x's and your y's, you graph those new points, and you mimic the same shape of the graph, but now we're going for a new set of points. So there you go for inverses. If you have questions, next tutorials are on Thursday, A and B lunch, room 1026. Don't forget, you have a quiz on Thursday.